Even a 15-minute build can be taxing on a user or a company. So by cutting down your build time, you save money by reducing the downtime of developers while they wait to get results for their latest code changes. A shorter build means that they can keep their repository clean of changes that can break the build. Because when build time is short, any commit can trigger a quick build to see that nothing is broken. Faster builds mean more builds and quicker cycles for detecting bugs and build breakages. And it also means you will have more time and opportunity to run tests producing a more stable product. And even those tests can be accelerated by Incredibuild. With Incredibuild, you simply need to install an Incredibuild agent on each machine on your network. Once an agent is installed, you will be able to monitor all the agents from our Coordinator monitor. For this demo, I'm using Azure Cloud instances, which I will now activate. But you can use any resources available to you, whether it's a VM, a physical machine, a cloud machine, or just an old server you have lying around in your office. When these instances boot up, you will be able to see that they are automatically updated on the Coordinator monitor. In this Coordinator monitor, you will be able to see the name, status, CPU utilization, and status indicators of your agent. This gives you a good overview of the resources available to you. For example, here we can see we have 6 machines which are subscribed to this Coordinator. In terms of picking which machines to use, Incredibuild works in a heterogeneous environment and it has its own technology called process level virtualization. So you don't need to have any of the source code or the build tools on the helper machine. That means that you can even install Incredibuild on any machine that is available to you, whether it's a developer machine, a build server, or even a secretary machine, and automatically use any idle CPU power that machine has, even if it doesn't have Visual Studio, make tools, or even environment variables. Once you have installed Incredibuild, you can then utilize the idle CPU power in order to accelerate any time-consuming processes such as build, unit testing, code analysis, or any multi-process task that you're trying to run. In the following example, I have loaded an OpenCV build which usually takes about 15 minutes to build on an 8-core machine. This is a good build to demonstrate on, as it is an open source build which I have made no modification to, so you can simply download it from source and try it out for yourself. To use Incredibuild, you don't need to make any changes to your code, configuration, or for your setup. All you have to do is once you install Incredibuild, you will see a new drop-down menu appear. To start the build with Incredibuild, use the rebuild from the drop-down menu of Incredibuild. Once you start the build with Incredibuild, you will be able to see a visual representation of your build being executed. This will give you an indication of the number of processes that are being run and other insights that are not usually visible to you. On the left, each line represents a single core from each machine. The first 8 cores on the left, cores 1 to 8, are the initiator machine, and any subsequent core after that are cores from helper machines which have idle CPU power that Incredibuild utilizes in order to accelerate your build time. So in total, you can see we are running 200 tasks at each given moment, simulating a CPU of 538 GHz, which of course is stronger than any machine you'd be able to purchase these days. These helper machines do not have anything pre-installed to them except for Windows as Incredibuild. Incredibuild on the run provides anything that is needed in order to finish the processing tasks on the remote nodes. The idea behind Incredibuild is to allow any machine in your organization to become kind of a super build node that can run hundreds of tasks at the same time, without changing your configuration or build, while utilizing any idle CPU power that you have across your network. Of course, some companies decide to put dedicated helper nodes, and some companies just utilize any idle CPU power, but that's up to you and how you want to configure it. Incredibuild is also fully automated and dynamic, so that means that I can add or remove helper machines as I see fit. So let's say you have a developer acting as a helper machine. If this developer machine is currently processing a task for another build, and this developer decides to go home and shuts off his machine in the middle of the build while processing this task, the build will not fail. Incredibuild will simply reassign the task to another helper. So there's complete fault tolerance, and you can be assured that your build will be finished successfully. When your build finishes, you will get a notification, and also the build history will be saved. So you can see the build here ran in 2 minutes and 6 seconds. And since you have a build history with Incredibuild and all the previous builds have been saved, you can actually review and compare your previous builds to your current build. So I'm going to open this exact same build, only running locally on the 8 cores, so we can see the difference in distribution, task creation, and build time. If I put these two builds execution next to each other, side by side, you can see that this is the exact same build executed once locally on the right and distributed on the left. Locally, it took, with only 8 cores, it took 15 minutes and 17 seconds, and distributed, it only took 2 minutes and 6 seconds. A good way to guesstimate your acceleration potential is to hover over the build graph on top of the build monitor and see how many waiting tasks we have that are waiting to be processed. For example, here we have 480 ready tasks. This means that we can add, in theory, another 280 cores into this build and get even further acceleration. From the visualized build monitor, you can get more information regarding the tasks that are running. For example, if you hover with your mouse over one of the teal color tasks, you will be able to see that this is a link process. Links are by nature set to run locally due to their high I/O usage, but this can easily be changed if you're interested to run them remotely as well. If you hover over one of the green tasks, you can see that this is a CLX execution, which has been sent to be processed remotely. Yellow bars represent warning and red bars represent errors. As you can see, you can just hover over the yellow bar to see the warning message, and you can double click it to see the regular textual output warning from the build. With this visual and textual output and the build history, I can simply save this build monitor, and I can collaborate with other developers, or if I'm a release manager, I can even send it to a developer to see how come this build finished its warnings.